Hello everyone, this is Jackie. So today I'm going to show you how to create a SolidWorks model of your Joukowsky wing. So you have generated your Joukowsky wing, and then you have using the MATLAB code to convert it into a form that's acceptable by the XML5. So you will have this data file that's generated from the MATLAB code. So what you will see in here is you will have two columns. The first is x-axis, which is chord Y location, and the y-axis, which is your thickness of the surface. So if you wanted to make sure that file is generated correctly, it will be the x-axis will be from around 1 all the way drop to 0 and go back to 1. So you will kind of sketching a profile from the trailing edge to leading edge and then coming back to the trailing edge. So with this profile, if you want to import this to SolidWorks, you still need a z-axis. So what I usually do is I will copy these data points into an Excel file and add automatically or manually adding the last column, z columns, which is all zeros. Okay, and then you can copy these and then save it to a text file. So in the text file generated here, I will have x, y, z location, and then you go back to SolidWorks, starting a sketch. So in here, first thing you want to make sure is your dimensions are correct. So you want to use inches, okay, instead of any millimeters and other stuff. Otherwise, your sizing will be incorrect. So go back to inches, and then in here we want to do insert, and when you want to insert a curve from x, y, z locations, and you want to browse the text file you just generated here, you will have the x, y, and z locations in here, okay, and then just click OK. Then you will see your curve is in here. So what you're gonna do is you want to actually convert this curve into a SolidWorks sketch. So select the front plane and then go to sketch. Click on this curve you insert and click convert entity. So what this will do is it will convert the curve inserted into a SolidWorks sketch. And now we can work on this sketch. In the sketch, you'll notice that the trailing edge there won't be a closed contour. So you need to close the trailing edge by just connecting them with a straight line. And then we can do extrusion. So select the curve and then do extrusion. So we wanted to generate a 4 by 8 inches wing. So the chord right now is 1 inch. So we want to make sure it's aspect ratio 2. So you want to extrude it to 2 inches. Then we're gonna resize it. So if you want to resize it, we can go to the mode tools. If you don't have this tab, just right click on there and then select the tool tabs, and you have the mode tools. In here you have the scale function. So you want to scale everything about the origin by 4 times. In this case, you'll have a 4 by 8 wing. Okay, and then we need to generate the holes for the inserts that will be used put into the model and then mounted on the sensor for your wind tunnel testing. So what we use is actually a extrusion expansion insert. So if you go to McMaster card, you go to here, you do expansion inserts, and then you go down to M4. That's the size we need, and then you use the flange one. Okay, in there you will have the dimension of your inserts. One thing to be noticed is the drill size for this. It's marked 5.8 millimeters. If you go to the description, the drill bit size is 5.6 millimeters. So you have to have a 5.6 millimeter holes in your model so that the inserts will stay in there very well. I do know my airfoil is kind of thin. Some of your airfoils might be really thin too. So in this case, for the inserts to stay well in the wing, we need to do a little bit modifications. So we do know that the wing should be mounted on the sensor center at its quarter core. So we need to generate 2 holes, which one is on the left side of the quarter core and one is the right side of the quarter core. This is a 4-inch wing, so the quarter core is 1 inch. Okay, so I do know that my wing is small. Some of your wing might be thick, you don't have this issue. But I do need to add another portion on the wing so that the inserts will stay there very well. So how I do this is I'm gonna go here, create a circle, okay, and the diameter for the circle, so the inserts is about 6 millimeter in diameter, Okay, so for it to be hold well in the plastic part or 3D printed part, it needs to have about 2 millimeter of wall thickness, which means that you need an extrusion about 10 millimeter in diameter for it to hold the inserts in the wing pretty well. So we'll make sure this wing is 5 millimeter. This whole circle is 5 millimeter in diameter. Okay, want to make another one that's also 5 millimeter in diameter. And then you want to place these wings. You want to change the location for this 0.75. And then the other one will be -1.25. So that will be around the quarter core. And the y-axis locations, you want to make sure these are about in the center of it. So 0.15 is a good number. Here, it just it depends on your airfoil. Again, if you have highly cambered airfoil, we want to adjust this a little bit. But you do want to make sure these two holes are actually on the same y-axis. Okay, and then we want to do a extrusion. So the insert is about 8 millimeter in the total length. You want to extrude it just a little bit more of that, so you have enough solid parts for the whole for the insert to stay. So I would just do 10 millimeter. So you want to do this, and you want to do a 10 millimeter extrusion. Okay, direction is not correct, so you want to flip it in there. So now we will have a little bit extended part here for the insert to stay well. So now we want to create the inserts holes. Again, that's 5.6 millimeter in diameter. So that should be 2.8 millimeter in radius. Okay, so that will be 2.8 millimeter. Then you want to do an 8 millimeter cut extrusion. And then the last step is to leave the space for the flange. The flange is 7.1 millimeter. I usually leave it a little bit bigger. So half of 7.5, I will do 7.5 millimeter in diameter. So that will leave us about 3.75 in diameter. Oops, sorry, millimeter. There we go. So 3.75 millimeter. So this is just a cut for the flange. The flange is about 0.8 millimeter deep. So you just want to leave a cut. That's 0.81 millimeter deep. So that will leave the cut for your flange. Okay, so that's good for the insert. And then the last little step is here. I will usually, do a little bit fillet on here. 0.1 inches is fine. So it's a little bit more aerodynamic. It looks good. Okay, so the last thing here is to put your initial on there so that we will have different wings. So you wanted to make sure you have the right wings. I usually put my initials on my wings. So what you do here, you draw a straight line first, okay, and you exit the sketch and then go ahead into another sketch on the same plane, and then you want to make a a text. You select that line as your reference and then put your initials. So my initial is Jackie. Here, JC. You can increase the font. So you actually change it to a much better font. This font, I don't really like it, so I usually do Times New Roman standard. Okay, can make it a little bit bigger, so I can make it 20 points. Okay, it's too big. So I can make it maybe 14 points. That's good. And then a little bit far away from each other. And then, or you can use other font. I think there's this might not, the Times New Roman might not give you a good cut. I think there are others. It gives you Jojo will work better. Yeah, Jojo might work better. That's better. So you have your initial right on there. Okay, so you select this, and then you do a cut about 0.4 millimeter deep. Okay, and wrong direction. There we go. There we go. So we'll have a 0.4 millimeter cut with your initial. So when it's printed, that's your model. But that's pretty much everything. That's how you can model your Jielong wing in the SolidWorks. And if you have any questions, feel free to email Sid and me. We're happy to help. Good luck, guys.